Hi, I'm Schuyler St and I'm doing the Arduino 101 course. So hopefully by the end of this class you'll know what Arduino Uno is and be able to program it. So first of all, how many of you have ever heard of Arduino? Okay. How many of you ever used Arduino? Okay, so I see everybody should hopefully learn something. So in this we'll go over what exactly Arduino is. We'll then go over the IDE, or the Integrated Development Environment for programming it. We'll do some examples of programming, and later on I'll tell you places where you can go to learn more from here. So what is Arduino? Arduino is an open source electronics prototyping platform. It has it's based off the Atmel a.k.a. 8 series. The current Arduino Unos, they use the a.k.a. 328, which has 32 kilobytes of memory. It may not sound like a lot, but it's big enough to store a lot of code. And most Arduinos are 8-bit, except for the Dewey, which is 32-bit, except that's advanced and we won't cover it. It's open source hardware and software. The IDE is open source, and the Arduino board itself is also open source. So if you want, you can integrate the Arduino board into your project. If you're building something, you can maybe do it. Or there are also Arduino derivatives like this Boarduino that is based off the Arduino. You can use with the Arduino IDE, but what the person did who made is they took the design files and they modified it because it's open source. So this is the Arduino Uno, and this is the board in real life. It's not that huge. So it uses a USB port, but the thing about it is that when you get it from Arduino or wherever you buy it, it's not gonna be, you can't use it like a keyboard or a mouse, but what it's gonna be instead is it's gonna be a virtual COM port, or it's gonna act like a serial port, but it uses USB, so you don't need to have a USB to serial adapter or something like that. Up here is the reset switch, and what that does is use it to reset the microcontroller to maybe like test it or for programming. This is the main a.k.a. 328 here. That's the main microcontroller. Depending on which version of your Uno you have, you might have the Uno SMD, which has a small black square there. It's the same chip, it's just in the SMD version, so it's mounted on the board versus a through-hole version. And there's no difference except that it's SMD versus through-hole. This chip up here, the USB interface chip, is actually another Atmel chip. It's the a.k.a. 16U2 for the Uno R3. And what that does is it acts as a USB to serial bridge. But the cool thing about it is with that header up there, you can actually reprogram it to act as a keyboard. Except for that, you'll need an external programmer, so it's not the easiest thing to do. Down here we have our power jack, and it also gets power from USB, but USB can only provide 500 milliamps, so if you're running like a lot of motors or you need something that uses a lot of power, you'll probably want to plug in a power jack here, a power adapter. It can take from 12 to 5 volts, and it'll automatically switch between USB power or the power jack, and you can actually have both plugged in at the same time too. That little gold thing there, it's a polyfuse or self-resetting fuse, and the way it works is it will allow up to about 500 milliamps to flow, but that's about what USB can provide. It's only for USB though. And then it gets really hot and it blocks the current from flowing because it's a temperature controlled resistor or a thermistor. What will happen is that say you maybe short out power and ground, or you do something that isn't good. That'll heat up and it'll then cause it to then block the power flowing so you don't damage anything. These silver things here, they're the clocks or oscillators for the Arduino. The big silver one here, it's for the USB chip. That actually uses a quartz crystal, which looks like a piece of glass. I've opened one up. And what it does is they're both at 16 megahertz, except that one, it's a quartz crystal because it needs to have very accurate timing for USB. This one here, it's a ceramic resonator, so it's less accurate, but it's good enough for the a.k.a. 328. This is your pin 13 LED, so it's an onboard LED you can use either when you're getting started so you don't need anything, or for debugging purposes. This header up here, it's your digital input-output header. The pins 0 and 1, they're being used for the serial communication to the USB, so in general, you shouldn't use those, but if you want to, you can. It'll just make it where you might have to remove the device that's hooked up to there during programming. Then down here, you have your analog ins. It has 6 analog inputs. So in general, you'll want to only use an analog sensor when you have to, because you only have 6 of them. And in their only analog in, it has a 10-bit analog to digital converter. So it'll go from 0 to 1023. And then down here, is your power header. You have VIN, or the raw power that's provided from the power jack or the USB port. It's not regulated. So keep that in mind if you use it. You have ground, and you have 5 volts, which are probably the most common things you'll use. You have 3.3 volts, which is more for if you're interfacing sensors that need 3.3 volts, like maybe a gyroscope or something like that. And then up here you have your reset line. That is so maybe you want to have this in a box and you want to be able to reset it. You can mount a button on the box so you can reset it. So now we'll go over programming the software. So the Arduino IDE, it has a compiler and everything. All you do is you'll download it from their website, and you'll then just extract it to, they recommend your desktop, but you can put it anywhere you want. It works on Windows, Mac, and Linux, and the language, it's sort of its own language. It's like a cross between C and Java, so it's really easy to use, and you have to deal with like pointers or complex stuff like that. And the IDE itself is also written in Java. So when you do the programming, you'll have 3 parts. You'll have your structure of it, which is like your loop functions and your setup functions and functions like that. You'll have your variables and constants, which you'll use for like defining pins or holding a value maybe from a sensor. And you'll have your functions that do stuff. So now we'll do an example to how to get this to blink an LED. Now it may seem like overkill to do it, but it's a really good way to get started with something that's simple. So what we'll want to do is we'll want to go into our Arduino IDE, the folder where we have it, and you'll just want to open the Arduino executable. You need to download and install it first. And if you have any questions on this, just stop me and I'll answer them. So for this, the first thing we'll need to do is plug in our Arduino. So you need a USB A to B cable, and you'll just plug it in. And if everything's good, the green power LED will go on. And if you got it just from the factory, this LED will be blinking as a test. So now we'll want to go into our tools and select our board and what serial port it's on. So we'll go under it, and under tools, and there's the board menu, and there are all these different boards. The one we have is the Arduino Uno, so we'll select that. And then we'll also go into serial port. The port this is on is COM4, I believe, so we'll just click that. And then what we'll do is so now we'll go over the IDE. Under the file menu, you have the open, save, and that stuff. You have it actually has a built-in sketchbook, which is where it stores all your programs you've made. I haven't really made any programs on this computer. I have one at home I use, so it doesn't show anything. Under examples, you'll have your examples up here. And down here are like libraries that you installed. So maybe like a library to interface with a sensor that uses like a protocol that is hard, that you don't want to have to program yourself. And then down here you have upload and upload using programmer. The difference between those two is, well, upload will compile it and send it over the serial port to the Arduino. Upload using programmer, what it'll do is it'll actually take an external programmer and it'll program it that way. Most of the time you'll just use upload. And then down here there's preferences. Under edit, the things that you'll probably use the most are comment, uncomment. So if you select code, you can just comment it out easily. And you'll also have find in reference, where is that? Oh, no. Oh, it's when you right click. So when you right click on something, you'll have find in reference. That it'll pull up a web page on the Arduino site with what does this command that I'm using do. So say you're interfacing something and you aren't sure what this command does, you can select it and do find reference and it'll tell you. You also have under your sketch menu, you have verify or compile. It'll just try compiling it, won't do anything else. You have show sketch folder. It'll show you where your sketch, your program is. You can import a library, so if you want to use one of the libraries, you have to import it. And you can add a file. That'd be if you have like an LCD and you want to display a picture on it, you'll import in a library. Under tools, we have auto format, which makes your program look all nice and neat. You can open a serial monitor, which will connect to the Arduino with a serial port over the USB serial port. So maybe if you're getting debug information that way, or if you're maybe trying to get it, like do some communication thing with it. And you have your board and serial port. Down here you have your programmer, so these are the programs that it supports. And then you can burn the bootloader. Say you get a fresh chip from like DigiKey or Mouser, you'll need to burn a bootloader onto the chip to program it without having to use an external programmer. Under help, you have different help websites. So first what we'll do is we'll go to the open menu, that's the dashed line with the up arrow, and we'll go to basics and we'll select blink. So what this does is up here we have it tells us what it does. It blinks the LED on pin 13. We actually won't need to add an LED because it already has one here, but we can if you want to. Here it defines integer LED equals 13. So it's essentially saying it's creating a variable that is named LED and equals 13. So that way you know what it is and it makes it easy. Say you want to change it to pin 5, you can easily change that. Next we have our setup command. This will only run once and then it'll go to the loop. So first we have pin mode. And what pin mode does is it says, is the pin an input or an output? In this case, we're saying that the LED pin is an output. The Arduino IDE is case sensitive, so for things like output, high and low, they all need to be capitalized. For a command that has 2 words, typically the second letter, the second command, its first letter is capitalized, but that might depending on who wrote the code. Now we go to our loop. Our loop runs forever. What it does is it does a digital write command, or it turns the LED, or it turns the pin high or low, and then it's LED, or which the pin it's on, comma high. So what that will do is it'll turn that pin on. Then it does a delay command or a wait for 1,000 milliseconds. So it'll wait 1 second. Then we go into digital write, LED, comma low. So what that'll do is it'll turn the LED off. Then we have another delay command that'll wait for a second again. So what we can do is we can click the upload button to send it to our board. So right now the white text you'll see, that's it compiling. Well, it depends on if you have in preferences, you can actually have it enable verbose output where it tells you more stuff, but in this case it won't. It says it's done uploading. And now, if we look at our Arduino here, you can actually see that this LED here, that's the pin 13 LED, it's blinking. So, you just made an LED blink, yay! So now we can do some more advanced stuff than just making an LED blink, because unless you want to have a nice big blinking lamp in your house, I don't really think you want a blinking LED. So let's add a button to it. You can use a button to turn the LED on and off. So we'll go back to our computer, and now we'll open another program. We'll go to open, and we will go to digital, because it uses digital input output, and we'll go to button. So what that'll do is, let's see if I can get this to stay here, is that it'll use a button that will hook up on the breadboard, and it'll use that to turn the LED on and off. So in this case, what we'll do is we'll have our button on digital pin 2, and our LED on digital pin 13. Then when you go down here, we have a third variable now. button state. That is the button high or low, so it knows what to do to the LED. And in this case, it equals 0. If you notice here, it says CO const or constant. That is a way of saying that these variables here, they can't change, just so maybe if you like type the wrong variable, you won't mess it up. So now we go into our setup command, and it sets the LED pin to an output. Except this time, because you have a button, we need to say that the button pin, or the pin the button's on, is an input. So that's all setup does. Typically in setup, you might initialize some libraries and do stuff like that. You won't really do that much of your code there. Then in loop, we have our button state equals digital read button pin. So what that does is it says is the pin the button is it on high or is it on low? And what it'll then do is it assigns that to the variable button state. That variable could be any name. In this case, they called it button state. Now we have an if statement. So if the button state, which you put in parentheses, equals high, so if this statement is true, then it'll turn the LED pin high or on using the digital write command. And then else, digital write LED pin low. So if it's not that, then turn the LED off. So what we'll do is we'll upload the code. And while it's uploading, I'll go over assembling the circuit on a breadboard. So on a breadboard, it has rows connected this way, like this, along here, but they don't connect over this well here. So for it, if we wanted, we could put like an IC or integrated circuit here, and then we'd hook up wires here. And then these rails up here are power and ground rails, which we'll get into later. So what we'll do is we'll get out our jumper wires. And the first thing we'll want to do is we'll also want to get out our button, because we'll be using that. So in here, we'll open up our button. So this is a button, and the way it works is that these contacts, you'll notice that this side's slightly longer than this side is longer than this side. It's because the pins are connected this way and this way, and then when you press it, it connects them this way. So what we'll do is we'll just insert this in the well, across the well right here, and we'll push it down. Sometimes the buttons don't always stay well and they'll need a little more pushing. And now we'll get out our jumper wires so you can hook up the button to the Arduino. Now for the button, we can't if we just hooked it up, so the button was hooked up directly to the pin and a voltage, because you need to provide a voltage. You can't just say the button is open or closed on the pin. What happened is it acts weird. So what we'll do is we'll take a jumper wire and we'll hook up one end of the LED of the button to say this side, and we'll hook that up to digital pin 2, because that's what it says in our code. And then we'll hook up the other side of our button to power. And what that'll do is it'll provide power to our button, so it will say when it goes high, press the button. So the power line, it's the fourth one up from the bottom of this power header here. 1, 2, 3, there. And they actually added more pins to these headers on the Uno. They have I2C interface here, which is actually just these analog pins, so don't think you're getting any extra pins. And they have like an I/O reference level, which is if your board's like 3.3 volts, if the shield's set up properly, it'll actually change its levels to be at 3.3 volts. So now if I press the button, did the code upload? Okay, it didn't upload right. Let's try that again. Hopefully it uploads properly this time. So for is it still uploading? Okay, so on here, it's giving us an error here. AVR dude, STK500, get sync, not in sync, no response. Essentially what that's saying is that it's not getting anything from the Arduino. So what you can do is you can either check that your COM port is good, or sometimes just unplugging and replugging your Arduino will solve the problem. So now we can try uploading it again, and it should go. So now it says it's done, And if you go over to the camera, we will see that when you press the LED, it acts weird. Like when I put my hand here, it acts funny. The reason is because of like the RF electrical noise that's floating around. What's happening is that it's picking up all that noise because the inputs here are high impedance. So like by putting my hand here, I can do weird stuff. So what we'll do is we'll add in a resistor. In this case, we'll use a 10 kilo ohm resistor or 10,000 ohms. And that is a brown, black, orange resistor. The resistor color codes, you can memorize them, or you can go online and find the web calculator for it. So what we'll do is we'll change this where I'm going to put the 5 volt here and ground and the digital pin here. But now I'm going to hook up my resistor to an empty row on the breadboard here and the button on one of the pins of the button. Then I'm going to get another jumper wire and I'm going to hook it up to, let's see if I got, I'm going to hook it up from the resistor to ground. So now what will happen is if any noise gets in, because these wires are really long, so they act like antennas, and even if you use short wires, it'll still happen, so this is a good design. What will happen is that any noise that gets in, it will then have enough power in it to keep at higher than about 3 volts, even with the resistor connecting it to ground. So the 5 volt rail can do that fine and the LED goes on here. But noise can't do it. So now we've just gotten rid of our noise. Now for the pull-up resistor, it can vary anywhere from about maybe 1 kilo ohm to up to 10 kilo ohms. It really doesn't matter. All that is changing is is how much current it draws when you press the button. So another thing you could do is if this LED is too small or hard to see, we can get a big LED, well, bigger. And the LED, it has a short leg and a long leg, and it also, on some LEDs, they'll have a little flat spot, which you might not be able to see when it focuses. Okay, so, well, there's a flat spot here, and it has a long leg and a short leg. What that does is that LEDs are polarized. They're a diode, light emitting diode. So what you have to do is you have to hook them up the right way. So what we'll do is we'll hook this up this LED with the short leg or the negative end to ground and the long leg or the positive end to the pin 13. So now the LED goes on when I press the button. Wrong way. So now when I press the button, the LED goes on. Yay! Now you can make a buzzer for your door. Wait, except you might already have one. So now what we'll do is we'll go back to our computer and we'll do something a little more advanced. This time we'll use analog input or the varying input. So it'll vary from 0 to 1023, which is 10 bits because the Arduino, it has a 10-bit ADC on it, or analog to digital converter. So we'll go and open and we'll go to analog and analog input. So what this does, if we read the comments, we have a potentiometer attached to analog input 0. And then it tells you how to hook up it, which I'll go over. And then an LED hooked up to digital output 13 and ground. So now we'll go over the code for this. So what it does is it starts by declaring the variable. So first we have int sensor pin equals A0. So the A has to be capitalized, it's analog 0. And depending on who writes the code, they might do const int for constant, or they might not do it. It just depends on your preference. Then we have LED pin equals 13, so pretty much the same as the other ones, and sensor value equals 0. Now what we do is we go down here and it says the LED pin is an output. Now the reason it doesn't have to say that analog pins are an input is because they are already set up as an input, because it's only an analog input. Then we have sensor value equals analog read sensor pin. So pretty much the same thing as doing a digital read except analog read. Then we do digital write LED pin high. Then we wait for this value here, or sensor value. Then we'll turn the LED pin off, and then we'll wait sensor value. So it's essentially the blink program, but it's modified so the time it takes to blink, it equals the value from the analog to digital converter. So what we'll do is we'll upload it, and here I've enabled verbose, so you can actually see that the red text is AVR dude, or the programmer, and it's sending and receiving the code. And then up here, the white text is it compiling the program. So now if we go here, we'll see the LEDs blinking, and again, sort of weird. So what I'll do is I'll get out my potentiometer. Ooh, it spins. And what we'll do is we'll change this. So you can play with it while it's powered. It depends on if you want to. You may or may not be scared of blowing up your Arduino. I've done this before, so I'm not really too scared of it. So our potentiometer has these things that stick out here, and they're in our way. What we can do is the well on the breadboard, if we stick it in, we can get it into the breadboard enough so it makes a contact by pressing it on with these things in the well, because it's designed to be mounted in a PCB where you'd have like a special footprint with holes for there. So we have that. On this we have 3 pins. The 2 outer pins are the same resistance. So think of a potentiometer as being so here's your potentiometer and here's your resistor. I'm drawing it extra long for demonstration purposes. This is, say, pin 1, this is pin 3, and then the wiper is pin 2. So on it we will have 3 pins and then our knob coming out of it. What happens is when you turn the knob, you move this wiper. So when you turn it all the way one way, it's connected to pin 1. But in pin 3 has the highest resistance, or 10 kilo ohms in this case. This is a 10 kilo ohm pot, or 10,000 ohms. When you turn it all the way the other way, it then connects the other pin to it. If you're building something where you want to have a label for like this way is one thing, this way is the other, you might have to swap the 2 outer pins, or if it's inverted maybe. And then if we put it in the middle, what will happen is it stays it's about half the voltage. So if we make this 5 volts, so if we put 5 volts on pin 1 and 0 volts or ground, on pin 3, as we rotate pin 2, what will happen is, say this is exactly in the middle, it'll be at 2.5 volts. And this forms what's called a voltage divider. So it divides the voltage. Now say we turn this so it's 3/4 of the way from ground and 25% of the way from 5 volts. So it's maybe about here. Then what will happen, being at 2.5 volts, it'll be about let's see, 3.7 volts, I think. And yeah, that's right, about 3.7. So because it's then forming it has less resistance here and more resistance here. So that's how a potentiometer works, and now we'll hook it up. So what we'll do is like I said, the middle pin here, we'll hook that up to our analog input port. In this case, it's analog in 0. Next, what we'll do is we'll hook it up to analog in 0 right there. Next, we'll hook up our 5 volt line. Yep, that's 5 volts, to one side. It doesn't matter which side. Then we'll hook up our ground wire to the other side of the potentiometer and hook that up to ground. So now, depending on how we turn the potentiometer, it varies the blink rate. So here it blinks so here what's happening is it doesn't look like it's blinking. What's happening is that it's blinking so fast that you actually don't see it blinking. Instead, what you see is a still image, and what's happening is it's blinking very quickly. And we'll go over where you can use this later. So if we turn it a little more, well, the other way, we'll see it'll start to get brighter, and it's flickering. That has to do with the camera and it interfering, but if you look at it, you'll also see it flickers some too. And then if we continue to turn it the other way, we'll see it's blinking. So that's great, but say we want to change the brightness of this. Well, what we can do is we can go and upload a different program that uses PWM, or Pulse Width Modulation. So what Pulse Width Modulation does is, say this is a graph of it, and this is plus 5 volts, and this is 0 volts, and then this is time. What we can do is if we have it where it's 50% on and 50% off, so this is 50% on and 50% off, it is on for half the time, not for half the time. So because the LED, if you can vary the voltage some, but it doesn't work well because the way an LED works. What you do is you vary the pulse width. So this will be at half brightness. Say we change this so it's 75% on, 25% off. And I drew this perfectly. It's just that you're seeing it wrong. So this is 75%, and then this is 25%. So what that means is that now it's going to appear to be at 75% brightness. And then if we swap this so that it's high for 25% of the time and off for 75% of the time, it'll appear to be at 25% brightness. So what we'll do is the Arduino actually has a built-in 8-bit PWM. So what that means is you can vary the time on versus time off, and it has 8-bit resolution. So on our computer, we'll go up to Open, and we'll go to Analog and Analog In-Out Serial. So what this will do is it says our analog in pin, or where our potentiometer is analog 0. And here they use const to make it a constant. It depends on what you like to do again. And then we have our analog out pin, and that's pin 9. Now, you're wondering, why not use pin 13 like we've been using before? Why use pin 9? We'll go over that real quickly. Now we have our two sensor value. Now we have our sensor value, which is the value it reads from the potentiometer in the analog to digital converter, because that's 10 bits. So it goes from 0 to 1024. But the output value, the reason it needs two values is because 8 bits, or the resolution of the output for the PWM, it's only 8 bits, or 0 to 255. So we'll need to change that, which we'll go over in the code here. So in the setup, it has a serial.begin command, and then 9600. 9600 is the speed or baud, like old modem. 560,000 baud. Whoa. So this is, we'll go over this later, has a way of debugging it. And then we have here sensor value equals analog read, analog in pin. So pretty much the same as the other program, except the variables are named are different. Then we have output value equals map sensor value 0, 1023, 0, 255. So what that means is map, it takes one value, so in this case 0 to 1023. It can vary this much. It scales it down so it can only go from 0 to 255. So say it can now vary this much. And what we'll do with that is we'll use it to go from being 0 to 1023 to 0 to 255, so it scales evenly. So for this, you put the value to scale, in this case sensor value, you put the range it'll be at, and then you put the range that it'll be. So low, high for the out. If we were to put 255 here and 0 here, it actually swap it around the other way. Then we use the analog write command. It's sort of like digital write, except it's for analog. And it's not a digital to analog converter. It won't output a voltage, But if you make like an LC or an RC or resistor or capacitor filter, you can try and filter it out so it forms a voltage, but you'll have some noise on it because it's not perfect. But if you need better resolution, you can buy a digital to analog converter chip. So it's analog out pin, comma, output value. And then we have serial.print sensor and serial.print, serial.print, serial.print ln. This just means new line, and we'll go over that later. And then it waits 2 milliseconds so it doesn't like send out too much data. So we'll upload this, and here it's compiling, or the white text, and now it's sending it. And it's done. It's actually pretty fast. The Uno's the bootloader, or the program on the chip that reprograms itself. It's pretty small. And the other thing that does is it also is they've increased the serial rate, I think. So now, the reason we can't use pin 13 like we have been is, let's zoom in. See, is it in the shadow? Come on, focus. Jeez. Okay, so you can't see it. Well, let's see if rotating it helps. Okay, I'll get this to be more right side up. So here it says digital, and then in parentheses PWM. So what that means is that these pins with a tilde next to them, they can do PWM. Because PWM in the Arduino, it's a hardware feature, so it can only do on certain pins. In this case, 10, 11, 9, and 6, 5, and 3. All of the other pins, if you try and do it, I haven't tried it, but all that happens is it just doesn't do anything or something similar to that. I haven't tried it. So what we'll do now is we'll hook up our LED to pin 9, which is here. The long leg goes in pin 9 because that's positive. Then we'll go over to ground, or the 4th pin down from the top of this header. You'll see it's glowing. Now as we turn the potentiometer, its brightness varies from off to on, full on. Now the reason this doesn't flicker is instead of the blink rate varying from 0 to 1.023 seconds, or 1023 milliseconds, like the code we had before it did, it'll vary from, it runs at a couple of kilohertz, maybe. It ranges from 20 to 100. I'm not sure what it is. It depends on how they configure it in the little macro that does the analog write command. Because the way Arduino is, it's actually a bunch of little macros that'll do things for you to make programming easier. Because the way the program works for like the Atmel's programming thing is you have to write a whole port, which makes it hard if you have like some pins on, you need to like OR it, or if you want to turn it off, I think you need to do an XOR or something. But for this, so what it does is, I'll also see that this LED labeled TX or transmit is going. So what that means is that it's transmitting data to the serial port. So if we go into an Arduino IDE, we'll open the serial monitor either by clicking here, either by clicking on the serial monitor icon or here with like a magnifying glass, or we can go to Tools and Serial Monitor. Or if you want to get really fancy, you can do Control-Shift-M. So in it tells us our COM port. It says this is for when we send, which we don't really care about, and then our baud. So say we turn it up to like 115,200 baud, or bits per second. It acts weird, and it doesn't really work right because it's expecting data to be at one speed, but it's getting at another. So we'll set it back to 9600, and so what it'll do is it actually, every time you open the serial monitor, it'll reset the Arduino, and it does that so like maybe if you output it at the beginning, you'll get that. So what we have here is our sensor value, or 624 or 625, and if I turn this all the way up, we'll see at 1023, it's only outputting at 255 because of the map command. And then if I turn this in the middle, let's see, so that's up. If I turn in the middle, it's at 103, so I can try and get to 112, or, oh yeah, I'm close, 117. It's at about 470, so about half. It's not perfect. And if I turn all the way down, they're both 0. So the serial will actually slow down your sketch because it takes time to send the data. So what we can do is you can select it and then right click and do comment, uncomment, and then we can comment out this. And we can upload it and it'll be faster. You probably won't notice it, but if you're doing something that has like timing in it, or maybe you're debugging something with serial, you then will probably want to comment that out when you do it, like when you have it working, because the serial, what it can do is it can actually slow it down. So now, here we see that the TX LED isn't blinking, isn't on, and the RX LED isn't on either. That's because what's happened is because we commented that out, it's not doing anything. So here we can see when we turn the knob, it does the same thing. And when you upload it, you'll actually see those LEDs blink a lot because of the way it programs it. So these are the examples I've gone through. And let's go back to here. So now we've gone through our examples, and I'll tell you where you can get stuff. So Radio Shack is a great place. This is our local Radio Shack. Over here, they have a bunch of shields for Arduino. Shields are boards that, let me get some of my shields, that plug on to the Arduino to give it extra features. This one, it has a ISD 4003 chip, and that you might find it in your answering machine at your house. It records sound so you can play it back. So maybe you want to have your Arduino talk, you can do that. There are some other shields that also do it, but this is the one I happen to have. This is a proto shield, or that Adafruit made, and it has a space for breadboard, or if you don't stick on the breadboard, you can just solder on components. It has the reset button over here. Radio Shack is a really great place to get kits for about $80. You can get the Getting Started with Arduino kit and the Getting Started with Arduino book. They're separate items, but I really recommend them. It's only $80, and there's actually the Netuino, which is based off the Arduino, and you program it in .NET using Microsoft's Visual Basic Studio thing. And so this book, it actually will go over a lot of the examples I gave. And one thing that's really great about Arduino is for the Arduino, it's created the Arduino, it's not just a board, it also is a footprint too. So all the shields, we can actually, here's an older version, the Due Melanove. This chip here is just a USB to serial converter. It doesn't do anything more than that, so you can't reprogram it like you can on the Uno to act as like a keyboard. So for shields, you can easily just plug one on, and they all use the same footprint. So if you put stacking headers in your shield, or headers that have a female top and really long pins, they're also called wire wrapping headers. You can like plug on one shield and another shield. And if you use more stacking headers, you can put on even more shields. So what that allows you to do is it allows you to add a lot of functionality to your Arduino that you wouldn't normally have. Where you can go, you can also get more information at Arduino's website. They have a getting started guide, which is like how to install drivers and stuff like that. Because installing drivers on Windows is fussy. I actually, on my computer at home, I had issues with it and I had to go in the forums and search for it. The playground is where, say, you make a shield or something that you want to document, but you don't want to host your own website. On the playground, you can have it's like a wiki on the Arduino website where you can post like libraries and stuff like that. They also have tutorials and examples that go with the examples I was showing you that are included with Arduino. You can also go to ladyada.net. It's run by Adafruit. And Adafruit is the store, and ladyada.net's where you learn. They don't have any ads, which is nice. And they have these 5 lessons, 6 lessons, or well, 5 or 6 depending on how you count it, about installing drivers and doing stuff like that. There's also learn.adafruit.com, which is a new website that is just come out, and it's for doing, and it has other tutorials for Arduino and other stuff. And then you can go to, again, you can go to Adafruit, you can go to Evil Mad Scientist, or Evil Mad Science Labs, and they make Arduino shields and kits, and they actually have their own Arduino derivative that's like all through-hole components. And what's great about the Arduino is they only cost about $30, so you can get one for pretty cheap. You can go to Maker Shed, you can go to Radio Shack, so you can go to SparkFun, and there are a bunch of other places that I haven't listed here. And I'd like to thank you all for coming here. You can go to Heatsink Labs. They're at 140 West Main Street in Mesa, and they actually have Arduinos there, and you can go in and they can help you with Arduino stuff. So now I'll take some questions. Yes?
So have you heard of STAMP?
Yeah, so for, this is my opinion on STAMP, but I'm not representing anyone else.
What are the advantages and disadvantages?
Yeah, so for STAMP, it's sort of a pre-bundled thing that, it's like Arduino, but it's another thing that'll work. It's made by Parallax, but in my opinion, what I don't like about STAMP is, first of all, it's closed source, so to embed it in your project, you need to have you need to buy one, which I think it costs like $40 or $50 for the stamp, and then you need a programming board to program it, which is another $30 or $40. And the other thing about stamp is it's slow and it's really expensive. So like for this, say you have a project and you don't really need the stuff Arduino gives you now with a circuit board and you want to integrate it in it, you can buy one of these chips for like $4, program it and plug it in very easily. So Stamp it runs like a simplified BASIC, but it's slower than Arduino, and it's about this big, maybe like a Stamp sort of. So if you program with it, you could use it. I think there might be more support for Arduino. I don't really use Stamp that much, so I haven't really played with it. So yeah. Yeah?
What kind of big projects or big dreams you want to take?
Currently, I'm working on building a device that'll spray the birds in our yard when they try and eat our grass seed. So it'll have a motion sensor, and it's gonna integrate into our sprinkler controller. It'll actually probably use one of these XB Wi-Fi, not Wi-Fi, XB modules that use Zigbee, the Zigbee protocol. And what's great about these is that they're turnkey pretty much. All it is it's just like a serial bridge. It's really easy to set up. And what I'll probably do is I'll have like an Arduino in where our yard is, and I'll have like a few motion detectors, like one for each zone of our sprinkler, and then when it detects birds or our dog going in there because we don't want to, or people because we don't want them to squish our grass, it'll send a signal to another Arduino that's controlling the sprinkler system, and it'll use triacs, which are like a transistor, but they can control AC. So I have our old sprinkler box because we upgraded it, trying to figure out how to get the triacs to work, which isn't working for me, but I'm gonna get them to work. So it's gonna have it like spray the birds or whatever's there, so the birds won't eat our grass seed.
Cool.
Anything else, or?
Water.
Yeah.
For the grass seed.
Yeah. Anything else, or should I go over more examples? Okay, so yeah. So for Arduino, you can also say you want to interface like a servo motor. What you can do is you can here's an example of how you'd use a library. So here we include servo.h. Servo.h is a header file that points to where the servo.c or .cpp file is, and for the library. We then create the servo instance. Servo, this creates it, and then my servo. We then create a position variable, and in setup we'll attach it on pin 9. So then all this does is that's a for loop, and position equals 0. Position is less than 180 because the servo goes 180 degrees. And then it adds 1 to the position. So it'll sweep back and forth. That's all this does. Then writes the position to it, and it will wait 15 milliseconds. It'll then go to that again. And then it'll sweep the other way. It'll subtract 1. So I'll upload it while I get out my servo that I brought with me. So this is a servo here. And what it does is, let's see if I can focus. Okay, so what it does is it has this horn here, which it rotates 180 degrees. So from here all the way over to here. You can get continuous rotation servos, but this is the servo I have, and this is the servo I'm going to use. So for a servo, there are 2 ways you can control it. You can give it either pulses, and by varying the time from like 2 to 3 milliseconds, or 1 to 3 milliseconds, you can control where it turns. Or some servos, they support you using PWM. So that's another option. It just depends on what you do. So for it, in this case, I'll use the servo library. And the servo library, it also handles every second. It sends or every so often, I forget exactly how often, it'll send out a new pulse to the servo. So the servo keeps the position. So what we'll do is we'll hook up our servo. All we'll need to do is we'll need to move the blue wire to pin 9, because that's what's said in the code. We'll hook up, on the servo we have 3 wires, a black, a red, and a white or yellow. It'll vary a little, but it should be similar to this. So we'll hook up our blue wire to the white one. Make sure not to reverse the polarity, or the servo, I've heard they'll go boom, and they'll actually do it quite loudly. And then we'll hook up black to the ground, and then we'll hook up red to the middle one. And the servo, let's zoom out, is going. It's sweeping back and forth. So now, say we want the servo to go faster. Is faster, it can be better, unless it's things that you want to be faster. So what we'll do is in our computer, we'll change the delay from 15 milliseconds to let's do 5, and let's change the other one for when it goes back. Let's make that 50. So what'll happen is we'll upload it, and if we look, we'll see the servo. It will act so now it will go slowly one way, and it'll go quickly the other. So when it goes the other way, and now it'll go. So what you can also do is we can also hook up a potentiometer to it. So it essentially, what that program will do is, it's called knob, it uses a knob. What it'll do is it's actually a lot simpler because it doesn't have to index through. And I'm gonna shut off the servo. That way it doesn't make as much noise. It includes the servo library, creates the servo. As the pin the potentiometer's on, you don't, and so you don't have to include A0, but I think people do, because this, I guess, is an older code. And then it has val. You don't need to define something, but in general it's good to define as 0, because if that code was being used in a different time for something else, it might act funny. So here it attaches the servo, or says, yep, connect the servo. Then down here it reads it. It reads the potentiometer. It then maps the value from 0 to 1023. So just like the LED one, set to 179 degrees. And then it writes that to the servo, and it waits 15 milliseconds. So if we upload this, what we'll do is we'll hook up our servo to pin these pins like this. And now we'll need to hook up our potentiometer. Except we'll run into an issue. We don't have enough. Oh. Come on. So, except there's an issue here. We only have 1 voltage pin here. So what we'll do is, this is where we could use our power rails on our breadboard. We'll hook up power and ground from the Arduino. Let's see how I can fit this on here. Hook them up to the power rails. So we'll hook up -2 here. don't want to, if you mix them up, bad stuff happens. And we'll hook up positive to here. So the power rails are only connected on this side of the breadboard, not this side, so you could add jumper wires. I'm not going to because I don't really need to. So I'll get the potentiometer in. Now we'll hook up the potentiometer with some more jumper wires. So I'll hook up blue. The blue one is in the middle to analog 0. And now we'll hook up the orange one to, let's find an orange one. Okay, the orange one to power, or the red rail. Here, let's zoom in. Come on, focus. Okay, good. So here's potentiometer, and then we'll look up our orange one to power. Then on the other side, we'll get another blue one, I guess, because that's what I have, to ground. Right? Yep. So now, and then we'll hook up our servo too. So I'm gonna get longer wires. Oh, zoom out.
You're in a red.
You move the blue wire to the red.
Yeah.
Oh.
Don't do that.
Yeah. See, this is why you want your polyfuse to protect you. So we'll hook up, yeah, we want this to ground. Now it'll work. So now we'll get another long wire so you can have the servo further away. So we'll hook up one of these, so we'll hook up the blue one to red on the servo, and we'll hook up that to power. And then we'll hook up this one to the black one to ground. And when you turn the knob, servo, is it hooked up to the right pin? Okay, 0. I'm gonna get this to work somehow. See, yeah, so that's hooked up to the middle. This is hooked up to ground and power. Servo hooked up. Oh, now it's going. No. Oh. So, okay, now it is. It's slow. So if I turn the knob one way, it's shaking, I think, because of the way it talks with it or the servo or something. When I turn the knob, which is conveniently swapped around, so to swap it back, I can just swap the positive and negative on the potentiometer. So now when I turn it this way, it goes all the way one way. When I turn it this way, actually it should be like this. When I turn it this way, it's all the way this way. When I turn it this way, it's... something's not all the way plugged there. When I turn it... Okay. Yeah, so if I wasn't showing this to you, it would work. So, yeah, normally it works fine, but yeah, so if anybody has any questions about this, I'll take them. And
Way cool.
Well done.
thank you.